On a clear, dark night, you can see as many as 2,000 stars with the unaided eye. But there are actually about 200 billion stars in the Milky Way galaxy. And astronomers estimate that there are as many as 16 sextillion stars in the known universe. That's 16,000 billion stars. And that's an unbelievably large number, right? And it feels outside anything you could possibly experience. But 16,000 billion, the number of stars in the universe, is about how many molecules you'd find in just 10 drops of water. Wow. I mean, now I love this fact because it reminds me of two things. First, that in order to understand the world around us, you have to do some serious brain stretching, right? And second, that almost everything in the universe is invisible to us. It's kind of like that kid's book, The Little Prince, where he says, what's essential is invisible to the eye. And I always thought that was meant to be kind of metaphysical, like love. But actually, the more I learn about science, the more I realize what's essential is literally invisible to the eye. I mean, just ask anybody sitting on an airplane. Am I right? It's easy to take this invisible air for granted because at our size, we hardly notice it. But air is real. It's thick. Tiny winged insects, they don't fly. They literally swim through this soup of molecules that we call air. In fact, I like to imagine that we're all submerged in this ocean of air, full of yummy oxygen to breathe. And the reason that you can hear me is that my vocal cords are jiggling insanely tiny molecules that jostle other molecules. And this ripple moves through this sea of air like people bumping into each other on a packed train all the way to your ears. What's essential is invisible to the eye. Like when you put your lunch into the microwave oven, right? It's light. It's just light that we can't see, but it's just light that's heating up your food. Now, we can see some light. We can see red and blue, a small, tiny spectrum because we've evolved this thin strip of cells on the back of our eyes that are sensitive to this little tiny slice of a much larger spectrum. But can you imagine if we could see microwaves or radio waves? Your cell phone would be like a super bright light bulb, visible all the way to the nearest cell tower. It's all just light that we can't see. Now, most of the light we can see comes from our nearby star, the sun, right? But the sun sends out a lot more than just light. The nuclear reactions that create light and heat also send out neutrinos, particles that are so small and they fly so fast that they pass through all this stuff we call matter. Neutrinos simply slip between the atoms as they pass through everything, even our whole planet, hardly touching anything. And it's not like there's just a few of them. I mean, right now and every second of the day, you have over 100 billion neutrinos passing through every square inch of your body. What? I mean, there is so much more going on right here, right now, than we have any sense of. Scientists can now detect how time literally slows down when you ride a bicycle, or how you age faster when you climb a ladder. This makes no sense at all, but it's true. Now, I love blowing my mind with some amazing fact about the universe like this, at least once a day. It's a great practice to get into. You wash your face, you brush your teeth, you blow your mind? It's good. Here's a good one. This is a great one. About 25 years ago, the Hubble Space Telescope looked at a little piece of the heavens, like holding a grain of rice up to the sky. And it found worlds upon worlds. These are not stars. These are galaxies, each containing billions of stars. And in between them, it's all just space, right? But then, when we turn from telescopes to microscopes, we find the most amazing thing. Because inside every bit of matter, between the molecules, even inside the atoms, it's all just space. Think about it this way. Imagine that we could zoom in so far that a single atom was the size of this whole building, okay? And you learned in science that atoms are made of electrons that are orbiting a nucleus, right? So in our atom, this building, the nucleus is about this big. Again, the size of a grain of rice. And the electrons are not just far smaller, like dust, but they're way out there outside the building, separated from our nucleus by nothing but space. And these atoms, they bond together into constellations of molecules, much like stars clump into galaxies. And like stars, atoms rarely touch each other. There's a lot of space between them. You can see how all those neutrinos might get through, right? But think about this. Think about this. This is what you are made of. 30 trillion individual cells in your body. That's 30 million cells. 100 times more cells in your body than there are stars in the Milky Way galaxy. And each cell contains trillions of atoms. And each atom is made of what? A little energy and a lot of space. So from a certain perspective, you might say that we are essentially invisible. Now, certainly compared to the size of the universe, it's easy to see we are virtually insignificant. Bummer. But, and from a different perspective, we're also unbelievably huge in comparison to the size of the universe. In fact, I think it's that we can see both perspectives that makes us special. Because we humans, living here at this human scale, able to see almost nothing about the world around us, and yet able to discover and decipher so much, we possess something that appears to be extremely rare in the universe: the ability to choose. We choose to make the invisible visible. And when we choose, we learn, and when we learn, we stretch. And as the great jurist Oliver Wendell Holmes once said, a mind that is stretched can never go back to its own old dimensions. So, next time you look into the night sky, next time you look at a drop of water, remember to stretch. Beyond what we can see, beyond what we can even detect today, there's always more. What's essential is invisible to the eye, but it's real, and it's wonderful. Thank you.